Here is the circuit board of a Gree Inverter Mini Split air conditioner with a 1.5-ton outdoor unit. This circuit board is completely dead. The complaint is that they have checked the electricity in both the outdoor and indoor units, but the unit is still showing an E6 error code. The E6 error in a Gree air conditioner indicates a communication error. This communication error occurs when the wires are disconnected, not properly connected, or when electricity is not reaching the circuit board. The current situation is that this circuit board has completely failed. A new reactor has also been installed with this circuit board, and the electricity has been connected. A multimeter has been attached to monitor the electrical current. So now I will pass electricity through it to see whether this circuit board will work or not. Let's go ahead and pass electricity through it to check if it's receiving power. So, I've plugged it into an electrical socket. We are getting 229 volts on the multimeter, but the circuit board is out of order. There is no switching occurring, and no LED lights are glowing. So let's start the testing of this circuit board to determine the cause of why it is dead. The first test is a physical inspection. I have physically examined this circuit board, and it appears to be brand new, as if it has just been freshly soldered. I don't see any physical damage on it, not even on the backside. It's only a bit dirty, but otherwise there doesn't seem to be any issue. Next, I will check the fuse. This circuit board has a 25-amp fuse, and the fuse is perfectly fine as it continues to beep in continuity mode. Now, there is a second fuse here, which is located in the circuit along with the SMPS section. The value of this fuse is 3.15 amperes. Let's check this fuse as well. It's also perfectly fine. Both fuses are in good condition. Next, we will check all the high-side components of the circuit. After that, we'll inspect the SMPS. Let's see if we can identify the issue. There are two line filters here. If they were damaged, there would be visible signs of burning. Since this is a direct system, it's unlikely that the problem is here. Here we have a PTC sensor, which seems to have a significant value. Let's check its value to see if it's within the expected range. If its value is in kilo ohms, it could be causing the issue. I will test it now. The PTC sensor has silicon on its pins, so I'll remove the silicon first. The PTC sensor is showing approximately 47 ohms, which is perfectly fine. Here is a rectifier that's part of the SMPS section of the circuit. Let's check it as well. I've set the multimeter to diode mode and placed the red probe on the positive pin and the black probe on the negative pin. The value briefly appeared on the multimeter and then disappeared. I'll check the other pins with the black probe as well. This side seems to be fine. Now, I'll switch the probes to check the pin from the other polarity. The voltage drop readings are coming out perfectly fine. This means there's no issue with the rectifier in the SMPS section. This suggests that the capacitors in the SMPS section are likely fine since there's no visible physical damage. However, to be completely sure and eliminate any doubts, we'll test one of the capacitors. This will make it easier to proceed with further work on this circuit. Since all the capacitors are connected in parallel, checking one will give us an idea about the condition of the others as well. I've now attached the multimeter probes to the capacitor pins, and the beep isn't stopping. This indicates a short circuit. To confirm, I'll switch the sides of the probes and check again. Even after reversing the probes, the capacitor is still beeping continuously in continuity mode, which means there's definitely an issue on the high side of the circuit. Now we need to identify what's causing the problem on the high side. If these capacitors are shorted, they will need to be removed. But before removing them, let's test the other components. The main bridge rectifier, if shorted, could also cause this issue. Additionally, the diode, IGBT, and IPM could be faulty or short-circuited as well. So first, I'll check the rectifier. I'll set the multimeter to diode mode. The red probe is placed on the positive pin, and the black probe is on the negative pin. No value is showing up. Now, I'll switch the probes to check the bridge rectifier from the other side. This time, a value is showing. The bridge rectifier seems to be in perfect condition, and I don't see any issues with it. So now let's move forward to the diode that is connected along with it. The two pins on the sides are common points, while the center pin is the cathode, and the side pins are the anodes. Now, let's check them. I've placed the black probe, which is negative, on the cathode pin, the pin in the center, and the red probe, which is positive, on the side pin, which is showing a voltage drop. I'll take the probes to the other pin on the opposite side and check it. A value should appear, and it does, indicating that it's functioning correctly. Both anode pins should show a 0 reading, confirming that this diode is fine. Since there's a significant short circuit showing on the capacitors, There might be an issue elsewhere, but the IGBT seems fine. All its pins are showing a voltage drop, and none are reading 0. You can also see another IC, which is an IPM, Intelligent Power Module, and this IPM is for the DC blower motor. The outdoor unit has a UVW motor installed, and the entire circuit for that motor is located on this outdoor board. If the IPM is short-circuited, it could also cause issues in the circuit. However, right now, I'm checking the compressor drive circuit to ensure there's no problem there. Now let's proceed to test the IPM. I've connected the negative probe to the negative pin of the IPM and the positive probe to the positive pin. The first pin on the positive side is not connected. Moving to the second pin, the voltage drop is showing 0, which is unusual. Let's check the next pin, where the voltage drop is displayed. The third pin also shows a voltage drop reading. Now, I'll reverse the probes and check again. The second pin still shows 0 voltage drop, while the third, fourth, and fifth pins display a voltage drop. This suggests that the IPM might be shorted. However, I'm not entirely certain yet, because if any capacitors or other components are also shorted, they could be contributing to the circuit being dead. But given the symptoms, there's a higher likelihood that the IPM is faulty. In addition to the IPM, the issue could also be with the IGBT, diode, or rectifier. If the capacitor is completely faulty, it often swells, bursts, or gets hot, which are clear physical signs of damage. Now I'm going to desolder the IPM. If you don't have the right tools, it can be challenging to remove the IPM properly. As you can see, I've secured the circuit board on a stand that I made myself. Holding the circuit board firmly in place prevents it from moving around, no matter how much pressure I apply, because I tighten the screws on the stand. I've already made a video about this stand, and the link is provided in the description. For desoldering, I'm using an automatic desoldering station that I've set up. There's a possibility that the IPM is faulty, but other components in the circuit could also be at fault. I'm going to remove the IPM from the circuit first and test it. If it's defective, I'll replace it. You'll also need another tool, which is very useful, this U-type IC extractor tweezer. Let me zoom in and show you this tool. Notice how the ends are slightly angled, which makes it easier to grip and remove components from the board. I'll give you a quick demo of how this tool works. Here's a faulty IPM that I previously removed from a circuit. The tool grips the top side of the IC, creating a secure hold. You can make this tool yourself. It's not too difficult. Or if you don't want to spend time on that, I've provided a purchase link in the description. Now, I'll apply some paste to the soldering pads. Since I need to remove the IPM without damaging its pins, I'll reheat all the pins by adding fresh solder. My soldering iron is set to 300 degrees. I'll add new solder to each pin to ensure they are fully heated and easy to remove. This process should be done for both the high and low side pins. Additionally, there's usually a thin layer of silicon on the pins that should be cleaned off for easier removal. I'm using a desoldering station to remove the excess solder from the pins. The goal is to clean off as much solder as possible. If it gets thoroughly cleaned, that's great. If not, we'll handle it in the next step. The desoldering machine has sucked out the solder, and now most of the pins are clear. If they clean up nicely after desoldering, that's ideal. But if not, I have a solution that I'll share later in the video, which is a crucial point. If you only have a regular solder sucker, you can still remove the solder in the same way. Follow the process I'm using, and you should be fine. Now, all the points are well cleared. Here's the U-tweezer tool. I'll attach it to the IPM and start by removing one side. It's still not coming out easily, still too tight, so now it's time to use the hot air tool. I've set the hot air to 380 degrees with an airflow setting of 6. We'll gradually heat the IPM pins. The tool is already positioned on the IPM, and I'm carefully applying heat. But be cautious. Don't use too much heat, or components like capacitors might burst. Using a controlled heat gun like this one is important to avoid damaging other components. As we heat the pins on both sides, it will take about 5 minutes for the IPM to loosen. I'm applying slight pressure to the IPM so that as it heats up, it'll come out smoothly. You can see the pins are starting to come out. The first side of the IPM pins is now free. For the other side, you can use a nose plier. After freeing one side, gently grasp the IPM with the nose plier and apply downward pressure. I'll carefully heat it again, making sure not to apply too much pressure because too much force could break a pin. If a pin breaks, the IPM becomes useless. As you can see, The IPM has been successfully removed from the circuit board with all pins intact. I'll also test this IPM now. If any pin got bent during removal, don't worry, just straighten them gently to avoid breaking. If a pin does break, the IPM will be unusable. I'll now use a multimeter to test this IPM, as it was showing 0 voltage in the circuit board earlier. Oh, this point is showing the correct voltage drop. Let's check the next pin. There should be no reading on this pin. There shouldn't be any reading here either, and this pin should show a reading. Now let's move to the next point. There should be a reading on this positive pin, and this pin is also correct. I then move the negative probe to the other pin, and there should be a reading here as well. The second positive pin should also show a reading. This means the IPM is completely fine. So let's move on to the circuit board and check where the fault is. Let's check those points on the circuit board that were shorting, and they are still showing a short circuit, even after removing the IPM. There must be something else faulty here. Now I will remove these 4 capacitors. Actually, I'll remove 3, and the 4th one should reveal itself automatically. Now, see what I've done here is that I've removed all these capacitors, and the capacitors are completely fine. I also checked their ZNRs, and they are fine too, though ZNR usually blows the fuse. I just removed them to check for any leakage. The IGBT has also been removed, and it is fine too. The IPM is also fine. Yet, I still haven't found the short circuit. Whatever I check is showing a short circuit. That's why I'm thinking of removing the fan IPM. The compressor drive's IPM pad is still showing a short circuit. You can hear the beep sound from the multimeter. So let's remove the fan motor's IPM and check it on the circuit board. I've already removed the high side components, and I also checked the low side. There doesn't seem to be any problem. I've found the fault in this circuit. Look, this IPM was burst. It burst from the bottom, so it wasn't physically visible from the top. Moreover, it caused a short circuit across the entire circuit board. So, here is the IPM, and this is what it looks like. Let me show you a close-up. See, there's a crack here. In the next video, we'll further repair this circuit, so make sure to subscribe to the channel and click on one of the videos here. Thank you.